On this program, the drilling and extraction of oil, refining the black gold, and reaping the wind. Man's interest in petroleum goes way back. Even the streets of Babylon are said to have been paved with asphalt from bituminous swamps. A Canadian, James Miller Williams, was the first to successfully drill and operate an oil well in 1858. Since then, drilling rigs have sprung up all over the world in search of the coveted natural resource. Petroleum, nicknamed black gold because it is such a precious source of energy, is one of the most coveted natural resources in the world today. According to geologists, this natural mineral oil is formed from incompletely decayed plant and animal remains. Buried under numerous layers of sediment and subjected to high temperatures and the action of microorganisms, these remains gradually transform themselves into petroleum or crude oil. Oil occurs in deposits, usually at great depths beneath the surface of the earth. It is extracted by drilling a well deep into the ground. The most widely used technique is based on the same principle as the electric drill. A rotary drilling rig bores through the strata of rock. The drilling rig consists of a series of steel tubes called a drill stem. At the end of the drill stem is the bit. The bit consists of 3 rotating steel cones covered with sharp teeth that grind through rock. Drill stems rotate at a rate of 150 revolutions per minute through a rotary table installed on the rig floor. A force is applied on the bit. That force is produced by the combined weight of the bit and the drill stem to which it is attached. A hoisting system maintains an equal force on the bit regardless of the total weight of the drill stem. It is supported by a steel tower, the derrick, and is controlled by the driller. As the bit bores deeper and deeper into the ground, new drill sections are added. During the entire process, drilling mud, a mixture of water, clay, and chemical additives, is pumped under pressure into the hole through the drill stem. When the drilling mud reaches the bottom of the well, it is forced out through openings in the bit to return to the surface outside the drill stem. The drilling mud cools the bit and drill sections heated by the friction. It carries cuttings from the well to the surface. The drilling mud also cakes the side of the hole, preventing cave-ins and outpourings of gas or oil. Once drilling has begun, it continues non-stop until the oil is located. When oil is located, casing, steel pipe joined together, is run into the well and cemented into place. The casing wall and the cement are then perforated to provide holes through which the oil may enter the well. Perforators are lowered into the hole, down to where the oil is located. They are then fired electrically from the surface. Most of the time, oil does not gush out of the well. It is pumped out. The most widely used pumping system imparts an up and down motion to a piston. The piston slides through a metal tube submerged in the oil. When drawn up, the piston fills with oil, and when plunged down, it drives the oil to the surface. Another pumping method consists in injecting pressured natural gas into the casing. The gas expands, lightening the oil and forcing it to the surface. When oil comes to the surface, it is accompanied by natural gas, water, and sediments. To cleanse the oil, the mixture is sent to a large cylindrical tank where its components separate naturally according to their respective densities. The natural gas, very light, lies above the various fluids. It is then drawn off and sold or reused for pumping. The fluids are directed to a second tank to undergo separation. The sediments, heavier than the other components, fall to the bottom of the tank. The oil, less dense than water, floats on its surface. The water is returned underground through a dried-up well. The oil undergoes a second stage of separation to cleanse it completely. It is finally transported to a refinery by tankers or by pipelines. Pipelines are generally placed underground and can be hundreds of kilometers long. At various points along the way, powerful pumps push the oil along at a speed of about 6 kilometers an hour. The drilling, extraction, and transportation techniques used today are remarkably effective in meeting the world's insatiable demand for oil. In its constant quest for energy, humankind learned how to extract enough heat from wood and coal to cast metal and power steam engines. The advent of oil, however, marked the beginning of the Industrial Revolution. Petroleum could be converted into fuel, solvent, fiber, even paint and plastic. All these transformations take place in refineries. The oil extracted from the bowels of the earth is a complex mixture of various chemical compounds. In this form, it is of little use. It must be converted through refining into products that will be marketable. Crude oil consists of thousands of different hydrocarbons, compounds formed exclusively of hydrogen and carbon. It also contains impurities, such as sulfur and various metals. The combination varies widely from one oil field to another. To obtain maximum yield from a crude oil, it is important that its various characteristics be identified before its refining is undertaken. When a refinery receives a batch of crude oil, samples are taken and tested. Density is measured with a hydrometer. The density is an indication of a crude oil's quality. The higher its density, the greater its sulfur and impurities content. The oil's sulfur content is gauged with an X-ray machine. Once the testing is complete, the refining processes can begin. The first operation consists of separating the various components of the crude oil. The separation process is done by fractional distillation. The crude oil is heated to about 385 degrees centigrade and sent to a high tower. As the vapors of the different components or fractions rise in the tower, they cool. Since each component condenses at a specific temperature, it can be drawn off at a given level by pipes running from the sides of the tower. The lighter components, such as butane and propane, which remain in a vapor state, are removed at the top of the tower. Once liquefied, these gases can be used as fuel for ranges or water heaters. naphtha vapors condense slightly lower in the column and are drawn off to produce high-grade gasoline. Kerosene and diesel fuels are drawn off about midway down the tower. While diesel fuel can be sold as is, kerosene has to be distilled and supplemented with certain additives before it can be used as a fuel for jet airplanes. A heavier component called gas oil is collected from the bottom of the column. Finally, a residue of crude that does not vaporize is drawn off at the bottom of the tower. This is asphalt, or heavy fuel. Once the sulfur and metals have been removed, gas oil and asphalt are broken down into lighter molecules through a chemical process called catalytic cracking. The cracking products then undergo a series of distillations that convert them to gasoline. Besides various fuels, the refining of oil and related gases produces a base for a myriad of common use products, such as detergents, paints, and plastics. Polyethylene plastics, for one, are produced by polymerization, the juxtaposition of small molecules of ethylene. First, ethylene is obtained by cracking the gases collected from the top of the distillation tower. Polymerization of the ethylene is induced in an immense reactor in the presence of catalysts, chemical substances that promote the joining of the molecules of ethylene. The polymerized ethylene is recovered from the reactor in the form of a powder. Throughout the operation, the pressure and temperature conditions, as well as the concentration of the various reagents, are regulated and monitored from a computerized control center. The final step is granulation. A number of chemical substances are added to the polyethylene powder, after which it is heated and molded into thin rods, then broken into granules or pellets. These pellets are shipped to manufacturers of such diverse articles as packaging wrap or portable coolers. Two molding techniques are used to transform polyethylene pellets into a cooler. Blow molding, used to manufacture hollow articles, shapes the outside of the cooler. The pellets are first molded and heated. When the polyethylene has softened into a viscous fluid, it is introduced into the blow mold. Compressed air is blown into the mold until liquid polyethylene fits against the cool mold and solidifies in the desired shape. Injection molding, used to manufacture more resistant articles, shapes the handles. In this process, a piston injects pressured molten polyethylene into a mold. After cooling, the mold is opened and the article removed. To look at the final product, you would have to be well informed indeed to guess that one of the basic ingredients of this attractive cooler was oil. In the excitement of the industrial era, a key source of energy long exploited was all but forgotten: the wind. But successive oil crises and the scarcity of fossil resources have revived our interest in the breath of Aeolus, god of the winds. Modern society consumes energy at an alarming rate. We would be wise to develop alternate and, whenever possible, renewable sources of energy. One such source is the wind. Man has been harnessing wind power for a very long time. He has used the winds to power boats, to grind grain, to pump water for cattle and crops, and more recently, to generate electric power. Winds are caused by the unequal heating of the Earth's surface by the sun. At the equator, for instance, the air is warmer than at the poles. The warm air in these regions rises and moves toward the poles. As it rises, the air cools, becoming heavier. It redescends toward the surface of the Earth, where it produces what we call trade winds. These winds rush in from surrounding areas to fill the empty space created by the ascending masses of warm air. Trade winds are major systems that gust over more than half of the planet's surface. Due to their geographic location and specific topography, some regions are windier than others. These areas are particularly well suited for the installation of wind power facilities because the greater the wind speeds, the more energy it will yield. Wind energy must, of course, undergo a series of transformations before it can be used as electrical energy. This magic is wrought by a system called a wind turbine. A wind turbine is a device that rotates under the effect of the wind. Wind turbines have few blades, only 2 or 3, simply because more of them would not provide any additional power. Extending the length of the blades does, however, supply more power. Indeed, the larger the blade surface of a wind turbine, the greater wind energy it will extract. Made of lightweight, fiberglass-based materials, the blades have a carefully designed aerodynamic shape. The turbine must also be equipped with a device that allows it to follow the wind's changing directions. Another type of wind system does not need to be oriented into the wind because its turbine rotates whatever the direction of the wind. The axis of the turbine, which looks like an upside-down egg beater, is vertical rather than horizontal. Whether the wind turbine has a vertical or horizontal axis, the energy it extracts from the wind is converted into electrical energy by means of a generator. Propelled by the wind, the turbine blades turn a shaft to which they are attached. The rotation of the shaft is transmitted to the generator rotor. A generator consists of a crown of magnets, the rotor, set in a coil of wire, the stator. If you move a magnet close to a wire, it induces a movement of electrons, or an electric current, in that wire. So if a generator rotor is made to spin quickly, the magnetic field it emits creates an electric current in the stator. That electric current is then recovered by electric wires that will transmit it to where it will be used. The wind turbine is a system that can mean the energy self-sufficiency many of us dream of. Indeed, a small wind turbine can, for example, supply enough electricity to cover the needs of a remote cottage situated far from an electrical distribution system. The electricity produced by a wind system is stored in a series of lead batteries that provide self-sufficiency for 1 week. The current is then converted into an alternating current before it will power electric bulbs and household appliances. These small installations are not, however, the most profitable means of harnessing wind power. A highly promising experiment in this area is the wind farm, which consists of a large array of sophisticated wind turbines set up in a high wind location. Wind farm turbines produce an alternating current that can be made compatible with the normal electrical supply system. The numerous turbines of a wind farm are operated from a computerized control center. The operator's screen displays an aerial view of the wind farm. Each wind turbine is represented by a small square whose attendant color and digital data describe its status on an ongoing basis. The winds that sweep over the Earth's surface represent an enormous energy potential. In some parts of the world, such as the United States, the potential is so great it could meet the electricity needs of the entire country. They say you should never put all your eggs in one basket. Well, the same is true where energy is concerned. Let's not try to meet all our energy needs from a single source.